Welcome to Cool Guy Podcast. What mysteries lie on the opposite side of the moon?
So we got a ton of sources from you all about the, quote, dark side of the moon.
Mm-hmm.
And let's be honest, that name is probably one of the most successful pieces of astronomical misinformation ever.
It really is. That Pink Floyd album has a lot to answer for.
It does. So our mission today is to dig into what's really hiding on the far side and, well, put that album title back in its place.
And we have to start right there. There is no perpetually dark side.
Right.
The moon rotates, which means the far side, the side we never see, it gets just as much sunlight as the near side.
Okay, so wait. If the moon is rotating, how long does that hidden part actually stay in the dark?
A full lunar day is about 30 Earth days long.
30 days.
Yeah, so any given spot on the moon gets roughly 15 days of, blinding sunlight, and then 15 days of total absolute night.
So the real mystery isn't darkness, it's invisibility.
Exactly.
And that's because of synchronous rotation, tidal locking.
That's the one. Earth's gravity has sort of grabbed onto the moon and locked it into this perfect dance where its rotation and its orbit take the exact same amount of time.
So we are always permanently staring at the same face.
Precisely. And that meant the far side was a complete blank spot on the map until 1959.
With the Soviet Luna 3 probe.
Right, when it swung around and finally took a picture.
Yeah.
And when those first images came back, scientists were genuinely shocked. It revealed what we call the Great Lunar Dichotomy.
It is so striking. The side we see, the near side, it's covered in those huge dark patches, the mare, the seas, which are just ancient lava flows.
Right, it looks cracked, scarred.
But the far side looks untouched. It's just uniformly pale and completely saturated with craters. Why that huge difference?
Well, it all comes down to the thickness of the crust.
Okay.
NASA missions confirmed it. The far side's crust is about 30 miles thicker than the crust on the near side.
30 miles, that's a lot.
It's a huge difference. And that extra thickness is the master key. On our side, the thin side, magma could easily crack through and flood the surface, creating those dark seas.
But on the far side, that 30 miles of extra rock was just too much to push through.
It was an impenetrable barrier.
Exactly. And that difference, that massive thickness gap, has been a huge planetary science puzzle for, 50 years?
At least.
Oh.
But the leading theory now, which came out of supercomputer simulations, is honestly mind-bending. It's called the double birth theory.
The double birth.
The theory is that about 4.5 billion years ago, after the giant impact that created the moon, there weren't one, but two moons orbiting Earth.
Two moons?
Yeah, a big one and a much smaller one basically chasing it. Eventually they collided, but not in a violent smash-up. It was more of a slow, gentle merger.
Like a cosmic fender bender.
Kind of. The smaller moon basically splattered across the far side of the bigger one, smearing itself on top and created an immense, thicker second layer of crust.
That is incredible. So that explains the ancient geology. But what about today? Are there any places on the moon that are, literally dark and cold right now?
Oh, absolutely. You find them at the bottom of deep craters near the poles, especially the South Pole.
Because the sun is always so low on the horizon there.
Exactly. The sunlight just never, ever reaches the crater floor.
And these are the spots that are hundreds of degrees below zero.
Way below zero. It's why they're the prime target for missions looking for frozen water, ice delivered by comets.
But then where the sun is shining, it's the total opposite.
Brutally opposite. Temperatures can hit 200 degrees above zero. Without an atmosphere to spread the heat around, you get these insane extremes.
So if you stood there, the side of you in the sun is boiling and the side in shadow is freezing.
Instantly, both at the same time.
Which brings us to one last fact that I just find so hard to wrap my head around. With no atmosphere, there's no blue sky, no skylight.
None at all. The daytime sky is just black.
Pitch black.
The only light is the direct beam from the sun, so any shadow cast by a rock or the lunar module isn't gray. It's pure pitch black because there's zero ambient light to reflect into it.
So the far side, once this huge mystery, showed us that even our closest neighbor can have these formation secrets we're just now figuring out.
And it really makes you wonder, doesn't it? If we needed a complex twin moon collision to explain our own moon, what other foundational planetary mysteries are hiding in plain sight that we're still trying to explain with simpler physics?
Something to keep looking up for.